To solve this problem, the first thing I need to look up or find is how many pounds are in a ton. When I look this up, I find out that 1 ton equals 2,000 pounds. 1 ton is exactly 2,000 pounds, so our significant digits here are 4. So we have 4 significant digits. And when we put this number into scientific notation, we get 2.000 times 10 to the third. We also need to put this number into scientific notation. So we have 4,540,000 in scientific notation. So we move the decimal over 1, 2, 3, 4, 5, 6 spaces. We get 4.54 times 10 to the sixth. This number has 3 significant digits. So we know that at the end, our final answer should have 3 significant digits, since it's the smaller of our 2 original numbers given in this problem. Now we can move on to solving this problem. So the first thing we need to do is we need to divide this number, or actually we're going to use the scientific notation number, by 5, because we know that we have this much money in $5 bills. We want to know how many bills we have. So we're going to say 4.54 times 10 to the 6th divided by 5. We're going to regroup and put the numbers in one set of parentheses and our base tens in another set of parentheses. In this case, we only have the one base 10, so it's just going to sit by itself for now. When we do this math, we get that 4.54 divided by 5 equals 0.908 times 10 to the 6th. We need to put this number in proper scientific notation. So that means that this number must be greater than or equal to 1 and less than 10. To do that, we need to move this decimal place over 1 space to the right. So we end up with 9.08 times 10 to the negative 1 times 10 to the 6th. And we can regroup this problem now. So I'm going to go ahead and just erase these parentheses. Add back my 1 that I accidentally deleted. And we're going to change our parentheses to go around our base 10s. Now, we can use the product rule for exponents that says that when we're multiplying like bases, so both tens, we can add the exponents. When we do that, we end up with 10 to the power of 5. So we get 9.08 times 10 to the 5th. This is the number of bills we have. Now we need to divide the number of bills we have. Oh, actually, we need to divide, 2,000 pounds by the number of bills we have. And let's look at that right here. So we want to know how many pounds each bill weighs. So we have to put pounds on top. So we know we have 2,000 pounds, or in scientific notation, 2.000 times 10 to the 3rd pounds. And we're going to divide that by the number of bills we have, which in scientific notation is 9.08 times 10 to the 5th bills. So now we're going to again regroup. We're going to put the numbers together for this division problem, and we're going to put the 10 bases together. So I'm going to rewrite that over here. 2.000 divided by 9.08 times, and this sign still is a times, and then 10 to the power of 3 divided by 10 fifth. So now we can do regular division here, and we can use the quotient rule for exponents over here. So the quotient rule says that we subtract our bases. So we have 10 to the power of 3 minus 5 using the quotient rule. And this simplifies to 10 to the power of negative 2. Over here we do 2 divided by 9.08, and we get 0.220. Remember, we need 3 significant digits, so we're going to leave that as 0.220. All right, we need to put this number into proper scientific notation, so I'm going to write this as, we're going to move this decimal over one place to the right. So we're going to write this number as 2.2 times 10 to the negative 1. Again, we're going to go ahead and move our parentheses and so that they're grouped around our base 10s. And we're going to rewrite this number as 2.2 times 10 to the power of, remember here we're using the product rule of exponents, so that means we add the exponents, so we have negative 1 plus negative 2, which is the same as negative 3. So now we know that each bill weighs 2.2 times 10 to the negative 3 pounds.